The sun is as beautiful as it is powerful. Something we can oftentimes forget about in our day-to-day lives, with the exception of sitting in traffic and it's 95 degrees outside and the AC doesn't work. Despite the potential for sunburns and the slight discomfort you can get from it sometimes, it has the ability to affect each and every one of us in a much more adverse way. I'm going to talk to you today about a coronal mass ejection. So, by the end of the speech, you shouldn't be going out and stockpiling sunscreen. You shouldn't be going and buying a doomsday bunker, but perhaps consider how it will affect you when the lights go out. Being something I've been interested in for quite some time and watching every single episode of Doomsday Preppers, I've investigated this for quite some time now. So, the sun being a bit of an unpredictable ball of gas that has had an adverse effect on the Earth before, there's potential for it to do it again. But in order to understand what that effect may be, we not only need to learn about what the composition of a coronal mass ejection is, what the event was in the past that affected us so severely, and what the effect of a coronal mass ejection would have today. So, originating from the sun, it's easy to understand that a coronal mass ejection, we're going to call it a CME for the rest of the speech now, is going to be not only massive but extremely powerful as well. So, when the sun gets all hot and bothered, meaning that its own magnetic field contorts around itself, imagine a rubber band twisting, the energy released is either a solar flare or a coronal mass ejection. They are not one and the same, but a large enough solar flare can attribute to a CME. Imagine the sun as a giant cannon, the muzzle flash that comes from a cannonball being shot being a solar flare. A large enough solar flare causes the cannonball itself, a cannonball composed of billions and billions of tons of superheated, magnetized, radioactive plasma, space dust. Billions of tons of that cannonball being shot at 900 miles per second in any sort of random direction that the sun sees fit. At that speed, it would take approximately 3 days to get near Earth's distance. So, with the idea of cosmic cannonballs being shot in any random direction, the likelihood of it happening is extremely low, considering we are 92.96 million miles away. We're also spinning around the sun and the sun itself spinning. Not really going to happen. But on September 1st of 1859, a guy named Richard Carrington with his telescope saw two solar flares. Within minutes they disappeared, but within a couple hours the effects of those solar flares could be felt on Earth. What had happened was a coronal mass ejection interacting with Earth's magnetosphere caused a geomagnetic storm. We know about those because we have the auroras in the north and the south. With a large enough coronal mass ejection, though, you can get extreme geomagnetic storms. One that happened in the Carrington event, named after the guy who found it. Telegraph operators reported telegraph machines bursting into flames, some of them even being shocked, telegraph machines being completely shut down. Parts of the power grids, breakers and whatnot, blowing, bursting into flames. The auroras being so large and so bright that people in Cuba and Costa Rica could see them, and in the northern hemispheres it was so bright that people were getting up for work. It was 1 o'clock in the morning. So, if it had the effects like that in the 1800s, imagine what it would do today. It would be extremely detrimental. To give you some numbers, 2003, the GPS industry alone was worth about $13 billion. 2017 was estimated to be over $1 trillion. Just to give you an idea, GPS runs the satellites. Satellite runs absolutely everything. Your phone, to be able to call your buddy, goes to a satellite and back. And you swipe your card, going to go buy whatever you choose to buy. It goes to a satellite and comes back. Your phones, transactions, the stock market, almost every single form of communication the internet holding pretty much everything that runs your life, being your contact information. You're probably going to have information about yourself stored in some database. Your student loan debt stored on the internet might not be such a bad thing. At the end of the speech, you'll find out. The power grid's not necessarily being ran off the satellite, but as we learned previously, that itself was not protected from a coronal mass ejection. So, the thing is though, is that we currently have some satellites that are pointed at the sun to give us some forewarning. Yay! They are ready to give the power companies enough forewarning to shut the power grids off, temporarily causing blackouts, but in the long run, saving the power grid. Can't say much for your phone though. The reason we couldn't say much for your phone is because those geomagnetic storms, when they are large enough, I forgot to say it, causes almost an EMP, an electric magnetic pulse, which based off of my in-class survey, most of you knew about. So here we are, lights on, cozy, endless amount of info, and a nice little plastic brick in your pocket. Student loan debt, all stored as ones and zeros in some database somewhere, can all be shut off in an instant. But with all this cosmic info, the only thing that you really should be walking away remembering is that a coronal mass ejection really is just hot space stuff that probably won't hit us again in your lifetime, but has potential to. An old guy with a telescope found the relation between large solar flares and coronal mass ejection, and there's absolutely nothing you can do about it. So, not to scare you, don't go buy a bunker, but just remember the sun does not care about how many Instagram likes you got. So, thank you. Any questions?